All right, students, we're into the next section with radicals where we're adding and subtracting two or more radicals. So this follows up with the previous section where we were simplifying. So I'm on page 835, and you can see some boxes, some information at the top, and you can see how a problem is done by following the colors once again. If I'm looking at the part that has 2 root 5 plus 4 root 5, you can see how the numbers in the front, the 2 and the 4, get added together. 2 plus 4 is 6, and the square root of 5 stays the same the whole way through the problem. So your answer for the 2 root 5 plus 4 root 5 is 6 root 5. For the one below that, 6 root x minus 2 root x. Well, just like before, you can subtract now the numbers in front, 6 minus 2, and get 4, and the square root of x stays that way through the entire problem. What's helpful is to look at this box right here that describes like radicals and unlike radicals, because that's a key. Please take a look at these examples, A, B, C, and D, for example 1, and make sure it makes sense to get to the answer at the very end. Please notice how whenever we are simplifying these, it is possible, like in C and D, to get answers that have 2 or more parts to them. C doesn't simplify at all because the square root of 2 and the square root of 11 can't go together. D does simplify some, but you cannot put something that has the square root of 3D with the square root of 2D because they're not the same thing. You can only put things together if it's the square root of y in both cases, or the square root of 7 in both cases, or something similar. So I'm now on page 836. Page 836, example 2, and there's 4 of these. So these are what we're going to take a look at. Make sure you guys read the explanations off to the side if there's a step you don't understand. So I want to add the square root of 12 plus the square root of 27 in example A. First of all, I want to simplify the square root of 12. The square root of 12 is the same as the square root of 4 times 3. The square root of 27 is the same as the square root of 9 times 3. And you guys know that 4 and 9 are what? What are they? They are perfect squares, right? I could make the square root of 4 turn into a 2 and keep the square root of 3. I can make the square root of 9 turn into 3. So that would become 3 root 3. Follow the steps and make sure you understand that you could get to the point where it's 2 root 3 plus 3 root 3, and then you can add those together. 2 root 3 plus 3 root 3 is 5 root 3. The next example, B, is similar. You're going to add two things together, but you've got to simplify 3 root 8 first. Keep that 3 out in front. Square root of 8 is the square root of 4 times the square root of 2. You could do that. And then you know that the square root of 4 can become 2. Just follow the colors, guys. Follow the colors, and that's how you can tell what parts become what. So you get 6 root 2 over here. Over here, follow the steps and get 3 root 5. And something that has a square root of 2 is not going to combine with something that has a square root of 5. They don't combine. So that's the final answer. Take a look at C. Look at the steps in C, and you'll eventually get to 10 root 7x minus 8 root 7x, and those will subtract. Finally, take a look at D. There's a lot of steps to it, but you will eventually get to the point where you have 5 root 5b plus 6 root 5b minus 3 root 5b. Take a look at it step by step, look at the explanations off to the side, and make sure you can get 8 root 5b.